Okay, question 3 is a complex numbers question. It says solve the equation given your answer in the form c plus or minus di. So there's two different ways to go about this. I would either complete the square, I'd probably do that. I think it's more straightforward, there's less room for error. Or you could use the quadratic formula. So I've shown you both. So here's the method completing the square. So if you just want to pause the video and have a look at each step. And here's using the formula. So you pick whichever way is best for you. Okay, so because this is part B, it suggests that it's a kind of separate part to the question. So you're given this quadratic equation, and it says, sorry, the roots of that quadratic equation are w and w star, so they're the complex conjugates. It says, in the case where q is real, explain why q must be -1. The key to this is this. Alright, if you've got a quadratic equation that has complex conjugate roots, then all the coefficients must be real. It's like in part A. So part A, if you just go take the video back, we got -2 plus or minus 4i for the roots. They were complex conjugates, and that happened because all the coefficients in the quadratic were real. So the reason why q must be -1 is for this equation to have complex conjugate roots, all the coefficients must be real. This is real at the minute, this is real. How would you make that real? Well, to make it real, the i's need to disappear. So what value of q would make the i's cancel? Well, if you've got +1 there, you'd need -1 there. So there's my solution. I'm not the best at written work necessarily, but you just need to get the point across. So the 2 points where you get the marks here is saying that because it's a quadratic equation that has complex conjugate roots, so that's 1 mark, then it must have real coefficients. Therefore, this must be real, so therefore the way that would become real is that q is -1. That would get you the 2nd mark. So part 2 says, in the case where w equals p plus 2i, and where p is real, find the possible values of q. So, what do we know? We know that we've got this equation, and in part A we're told it has roots w and w squared. We're now told that w is p plus 2i, so I know this, and then I also know w star, the complex conjugate pair in there. I've got 2 roots and I've got a quadratic equation. Roots, quadratic equation, you should be only thinking one thing, roots are quadratic. So what could I do with these to compare with this? Well, we could find the sum of these. What would the sum of these equal? Well, the sum of these would equal the minus coefficient of z. Okay, think of your x squared minus the sum of x plus the product. So the sum, we've got the sum of my 2 roots, and as I've said, that must be equal to minus the coefficient of z. Okay, so I've written that in there. I've cancelled my 2 i's, and I've just got rid of the brackets there, so I've got this. Do the same with the product. Okay, so I've multiplied my roots together, and I know the product would be equal to the plus the product bit on the end. Expanding those 2 brackets, cancelling these, evaluating my minus 4i squared. Okay, the I squared gives me a -1, so that becomes a plus. And solving for p, I get the 2 values of p, which is plus or minus 4. Okay, p is real, we're happy with that, but we need to find the possible values of q. So I know p, and I've got this equation, so I can sub p in and I can find q. Okay, so taking this equation here, I've subbed p in as plus or minus 4, so it doesn't matter which way round, you don't define the top or the bottom, whatever. So plus or minus 4, 2 lots of that is going to give me plus or minus 8. And then I've got this. Now this is the trick here. Alright, it's very difficult for me to rearrange this. If I take qi over, I've got I, then I've got to divide through by I. We haven't done that. Instead of dividing through by I, if we times by I, well, I times by I will give me I squared, which is -1, removing the I from the q, which is what we want. So, times in by I there, I'd get that. Times in by I there, I'd get that. I'd get I squared here, and I'd get minus q I squared. So, my minus I squared becomes plus 1, my minus qi squared becomes plus q, and I now can rearrange. So we look at the two scenarios. So let's say I've got plus 8 first. Plus 8, if I took and added 4i over there, I'd get 12i, I'd take my 1 over, and that'd leave me with my q alone in here. So I've got q is 12i minus 1. The other scenarios where I've got minus 8i, I'd add 4i to give me minus 4i, and I'd still get the minus 1 there. So there's the two values for q. So you've got to remember complex numbers questions, as soon as it starts talking about roots, think roots are quadratic. If there's nothing else you can think of to do, find the sum, find the product. The chances are that is the correct method. Obviously there'll be some questions where it isn't, but it should be apparent. You're told it's got these roots and you're given that value. You need to do something with that. What could I do with that? Well, I know that this is a root and this is a root. Right, two roots to a quadratic suggests roots are quadratic. So sum, product are simultaneous equations and work from there. This bit is a trick. You've seen it now though, so hopefully if a question like that came up again, you'd be able to do it. They're not easy though, complex numbers, and I think the exam questions can vary more so than other topics, so it is something to make sure that you work through every exam question, and then you'll have seen everything they could ask.